Hello there, young detectives. Welcome to today's Explainer. We are going on a totally top-secret mission to solve the everyday mysteries of invisible science. Have you ever stopped to wonder about all those amazing invisible forces happening around us literally every single day? You know, things like the sounds we hear or that cozy heat we feel? Well, today, we're going to use our absolute best detective skills to uncover exactly how they work. So grab your imaginary magnifying glasses because we are about to make the invisible visible. Okay, so let's dive right into our very first mystery. Picture two astronauts working on a spacecraft, floating right next to each other in the vastness of outer space. Here's the crazy part. If they didn't have special radios built right into their helmets, they wouldn't be able to hear a single word the other person was saying. No way, right? They could shout at the top of their lungs and it would be completely, totally silent. But why? What in the world is missing up in space that we have plenty of right here on Earth? To solve this, we need our first major clue. And that clue is a pretty special science word: vibration. Now, a vibration is simply a speedy to and fro movement. Honestly, it's just a fun way of saying a super fast wiggle back and forth. It turns out, absolutely all sound is created by something vibrating. When a thing wiggles super fast, it actually makes the air around it wiggle too. Then, those invisible wiggles travel right into our ears as sound. But think about outer space. It's mostly empty. There basically isn't any air to vibrate. So, no air, no vibrations, and zero sound. Down here on Earth, though, we have lots of air and lots of things that absolutely love to wiggle. So how does this work with our favorite music? Think about beautiful musical instruments, like a guitar, a violin, or a harp. Then think about other instruments, like a flute or a saxophone. If sound is always made by a speedy to and fro movement, what exactly is wiggling? Well, for a guitar, it's the strings. When you pluck them, those strings vibrate super fast to make music. But wait, what about a flute? It doesn't have any strings. Actually, for a flute, it's the invisible column of air inside the tube that starts vibrating when you blow into it. Isn't that just amazing? And that brilliantly brings us to another awesome way we can make sound. Think about loud, booming drums. They don't use strings at all, and you definitely don't blow air into them. So what on earth is vibrating? Well, a drum has a super tight skin stretched right over the top of it. In science, we actually call this a membrane. When you hit a drum with your hand or a drumstick, that tight membrane vibrates up and down really, really fast. That speedy to and fro movement pushes the air and makes that big, awesome drumming sound. Now it's time for a hands-on detective experiment. I want you to gently put two fingers right on the front of your own throat. Got them there? Okay, now keep your fingers there and hum a little tune. Do you feel that? That buzzing, kind of ticklish feeling? That is actually a vibration happening right inside you. You have tiny parts in your throat that are doing a speedy to and fro movement to create the sound of your very own voice. You are literally a living, breathing sound machine. Feeling hot, hot, hot. Yep, you've successfully cracked the case on sound. Excellent work, detectives. But our mission isn't over just yet. We've investigated what we can hear, so now let's investigate what we can feel. Get ready for the amazing science of heat. To understand heat, we first need to understand temperature. Temperature is simply the measurement of the warmness or coldness of a substance. Basically, it's how scientists tell exactly how hot or cold something is. Imagine you have two glasses of water. One is a freezing cold glass of ice water, and the other is nice, lukewarm water you just heated up on the stove. They have different temperatures simply because they have different amounts of thermal or heat energy. So the really crucial part of this mystery is figuring out how our bodies actually feel these different temperatures. And honestly, this is one of the coolest secrets in science. When you carefully touch something warm, like a warm mug of cocoa, it feels hot to you because heat energy is actually transferring or moving into your hand. But what happens when you hold a freezing ice cube? It feels cold, right? Well, here is the big secret. It feels cold because the heat energy from your warm hand is actually transferring out of your hand and into the ice cube. That's right, you feel cold when your body is losing heat. You know, heat energy is a bit of a world traveler. It absolutely loves to move around. Scientists have discovered that heat actually has three invisible ways to travel. They are called conduction, convection, and radiation. Now, I know those are some pretty big words, but they just describe how heat gets from one thing to another, warming up our world. Let's look at some everyday examples to make sense of this.
How does the heat from the massive, fiery sun reach us all the way down here on Earth? By radiation. It travels right through space to warm us up. Now think about a cooking pot sitting on a hot hearth or a campfire. The heat travels from the fire directly into the pot because they're physically touching each other, and that is called conduction. And what about convection? Well, that's just heat moving through liquids and gases, kind of like bubbling, boiling water. So heat is constantly traveling all around us, making sure things stay nice and warm.
Let's recap our discoveries. Wow, we have uncovered some truly massive clues today, detectives. And, a good detective always reviews their notes. So, let's gather up all our discoveries for a rapid-fire recap. First up, we discovered that all sound is made by vibrations, which is just a speedy to and fro movement. We learned that strings, invisible air columns, and tight membranes all vibrate to make music. Then we investigated heat. We learned that temperature measures hot and cold. And amazingly, we feel hot when heat transfers into us, and we feel cold when it transfers out of us. You have all been absolutely fantastic scientists today. But hey, before I let you go, I have one final assignment for you. A brand new mystery to solve on your own. You've probably heard the annoying whine of a mosquito, the chirp of a cricket, or the buzzing of a honeybee, right? Well, my question for you is, how exactly do these noisy bugs make their sounds? What part of them is doing that speedy to and fro vibration? I want you to investigate, maybe ask a grown-up or look it up, and then drop your answers in the comments below. Keep exploring, keep questioning, and I'll see you on our next Explainer mission.